Then we're going to study the rates of change in the natural and the social sciences. We just needed to know the meaning of the derivatives. The derivatives, if you're given two quantity x and y that depend on each other, okay, those two quantity x depends on y, maybe y depends on x. So the meaning of the derivative, okay, this is just the rate of change in y with respect to x. Okay, why this is a as a rate of change in y with respect to x? Well, you can think about this. This is a picture. So this is x-axis, this is y-axis. The relationship between x and y is determined by this curve, okay? So x depends on y, y depends on x. And this is the point x. And then there's a change in x, we call it delta x. Okay. Now, the corresponding change in y is here. This is a y value, and this is a y plus delta y. So here's a triangle. Okay. Delta y over delta x is the rate of the average rate of change over that interval when x from x to x plus delta x. So this is a average rate of change, okay, in y over the interval from x to the x plus delta x. So if y is a position function and x is a time, that gives the average speed, okay? The delta y is the displacement, okay, over the time interval from x to the x plus delta x. And this is, so the difference will be delta y, and that the ratio is the rate of the average rate of speed. So if the derivative y with respect to x, this is actually is a limit as x approaches, delta x approaches 0, delta y over delta x. That's why that gives the instantaneous rate of change in y. So simply called the rate of change, okay, with x fixed here, okay? You fix x, then you let the delta x approach 0. So that is actually the derivative. The limit is the derivative. Now if y is written is given by this formula, the y depends on x, right? Then what is delta y? Delta y is a change of their values. So this is the delta y. Okay. So delta y over delta x is nothing but this. Okay. So clearly, when delta x approaches 0, the limit is going to be the derivative. Okay. So dy of dx is going to be the limit of this ratio. This is also simply denoted by f prime x. So you get a brand new function. All right, so that's the meaning of the derivative. Okay. Now sometimes two variables are related in very strange way. Okay. For example, if two quantity x and y are related by the following equation: x times y equals square root x squared plus y squared. So y depends on x, x depends on y. Okay, So dy over dx is a rate of change in y with respect to x. Dx over dy is the rate of change of x in terms of y. So when y changes, x changes. So what x depends, we view x as a function y. For the first one, we view y as a function x. Y depends on x. Okay. So we can do both. So let's do it. Okay. So we find we have to use that. Let's express it in slightly different ways. This is an implicit differentiation, right? We just learned that. Right. So now you differentiate both sides with respect to x. This is for the first one, x times y is a product rule. So you have two functions here. X is a function of x. Y is a function of x. So it's a product. So by product rule, it's going to be derivative of x with respect to x and derivative of y with respect to x. The right hand side, you have to use a chain rule. Okay? You have to apply the power rule first. Then you differentiate x squared with 2x. Let me put the 2x here, right? So actually it's just d squared dx, okay? And then the derivative y squared will be, okay? So that's the first one, right? All right, so I have x, I have this, and I got 1/2 x squared plus y squared to the negative 1/2. And here 2x plus 2y dy dx. Okay, we have to solve for the derivative. It's a little bit complicated, but we have to be careful and solve it. It's a linear function in the derivative. Okay, linear. Okay, so multiply this out first. So I get x times x squared plus y squared to the negative 1/2. Then I times y, x squared plus y squared to the negative 1/2, dy over dx. So I have two terms containing the derivatives. Okay, so what I'm going to do, I move the derivative to the same side. Okay, so have a dy over dx, and I move all the other terms to the right hand side. Okay, then I factor the derivative out and solve for that. If you don't like negative power, what you should do, you multiply the numerator and denominator by x squared plus y squared to the 1/2. Right? You can multiply this both sides, the numerator and denominator by the same term. If you do like that, you will get x minus y, x squared plus y squared to the 1/2. Here's x. So it doesn't matter which way you do. I don't see we can simplify it. Okay, so that's it. Now, how do I find the dy dx? The same idea, but you probably don't need to do that. Okay, to find the derivative yx with respect to y variable, you don't need to repeat the same procedure. Why? Because as a channel, right? This is actually just one of the dy dx. You know why? That's the inverse to each other. Okay. So how do I know that? Well, this is general, right? The derivative of x with respect to y is going to be the derivative of x with respect to x, then derivative of x with respect to y, right? No. I'm confused. So hold on, let me erase this first. Okay. Yeah, this is inverse function. Okay. Let me explain to you why this is true. dy of dy, okay, it's going to be 1. Okay, clear. Now that is dy or dx and dx. Okay, now it's clear. So that is the reason, yeah, that gives you the above. So since we already find out the derivative of the y with respect to x, I just turn this upside down. Right? You don't need to waste time to repeat again. Repeat the procedure. Fine. Okay. Anyway, the derivatives are expressed in terms of x and y. So x and y related by this equation, then you can view y as a function of x, you can view x as a function of y. Then you can find that derivative using implicit differentiation. Okay. You can also view x and y as a function of another variable, which is hidden. Okay. For example, you are given, yeah, let's look at the first, the simple one. Okay. Yeah, x squared plus y squared equals 10 squared. Okay. Now what's that mean? Where is this from? If you look at a letter, okay, this is 10 feet long, and this is y, this is x, and no matter which position you put, x and y are related by this equation. This is Pythagorean theory. Okay. So when y increases, x decreases. When x decreases, y increases. So when x changes, y changes. So y depends on x. But you can also view x as a function y, because when you change the height, right, and then you also change the horizontal distance. Okay, so when make the y change, you have x change automatically because they're related. Right. So if you differentiate both sides with respect to y variable, x variable, then yeah, you just differentiate both sides with respect to x. Yeah, the derivative x squared plus y squared equals this. Then you get 2x, 2y, dy dx equals 0. Okay. Then dy dx equals negative x over y. Now I choose a simple equation so I can repeat the same procedure to find dx over dy. Okay. But if you differentiate both sides by with respect to y, what do you get? You get, okay, be careful. So derivative of x squared with respect to y. X is function y. So it'll be dx, 2x dx d over dy. And this is just 2y. Then it equals 0. Okay. So dx over dy equals negative y over x. Okay. You compare those two. You find out they're just the opposite to each other. Okay. X over y is the reciprocal of y over x. Okay. So you get dx over dy is going to be, it's going to be, yeah, y over x, first of all, it's going to be negative x over y. Okay. And that is going to be negative dy over dx. So you can also get this identity directly. Yeah. Yeah, very often you will see some quantities are related by some equation. Then you talk about the rate of change, okay, in one quantity with respect to another quantity. Okay. Now sometimes you can even change. Let's look at this equation again. Okay. maybe both x and y a function of another variable. That's possible. Okay, it's possible both x and y are function of the time t. Okay, and we are going to study this later. I think it's called related rates. So look at this, right? This is 10 feet. If this is x, this is y, maybe x changes with respect to t. So x increases as time passes. In that case, x depends on time t. Okay, and then since y and x are related, so y also depends on time t. When t changes, the y value changes. In that case, you just differentiate both sides with respect to t, not x, not y. If you do like that, it's implicit differentiation, okay? Implicit differentiation. But here we view x and y as another variable, which is time t. Then both, you see here's x squared, here's y squared, right? The derivative is taken with respect to t. So the first term is 2x dx dt. The second term is 2y dy dt. It's going to be 0, okay? Then it's up to you how do you solve it, right? If you want to solve the derivative of y with respect to t, you get a negative 2x over 2y, just x over y, and the dx dt, okay? So that's another argument coming from the implicit differentiation. All right, so those are the now, why we do want to study that? Sometimes study rates of change. Think about the Earth, right? The Earth, we assume the Earth is expanding, okay? And every year, expanded by, like the radius expanded by 1 millimeters, for example, just a little bit. How much surface area is created, additional, because X is the surface area. It could be a lot, maybe larger than your backyard. Okay? Even the radius of the Earth is only increased by 1 millimeter, for example. So we can do this kind of calculation. Okay? So yeah, we want to know the rate of change of the surface area with respect to the radius. Okay? So let's look at the problem here, the surface area. Okay, that's Earth. It's surprising, all the planets are around this, almost around the sphere. Okay, because they keep rotating. If they're not rotating, then just flying in the sky, then it'll be a long, like a cigar, right? It's rotating. Eventually, will make everything round, yeah. Or maybe elliptic type. All right, so this is a surface. If you want to study, if you want to understand, describe the surface, you need more advanced geometry. Okay, we have a course that for course 462, math 462. Okay, if you want to study flow mechanics, you should take this course. But differential geometry. Okay. If you take an electrical engineering course, then you don't need it. All right. Electrical engineering, you focus on more differential equations. That's why you have to take 266, I think. Mechanical engineering, you need to understand more picture, graphs, okay? Less about PDs, ODs here. Then you have to study more geometry. Okay. All right, so this is a sphere. I hope you still remember the formula for the surface area, because that's the minimum requirement for the SAT. If you take SAT to get to college, yeah. If you buy any book, to prepare for the SAT, and there's a page of the formulas you should know in geometry. Okay, so the surface area is going to be right 4 pi r squared. find out. Pi is actually coming from the area of the circle. Yeah, pi is, and yeah, this circle, the area is going to be pi r squared. Okay, pi is a special number, but that is a the surface area. It's a 4 pi r. Okay. And this is how does surface area depend. So it's not easy to understand how to define surface area. Right? How to define? It's not a flat. It's curved. Right? Surface. Right? If the surface is so large, I mean relative to you, right? You only about like 5 feet. But if the surface is a sphere is too large, then you say the sphere is a flat. Okay, that's why 100 years ago people thought the Earth is flat. Okay, flat. I only have an east, west, south, north. That's it. Okay, because I cannot look further because you are in the forest, right? You're in the jungle. How can you tell this Earth is a round sphere? You're so tiny compared to. All right, so this is a surface area. A equals 4 pi r. And we want to know the rate of change. The rate of change in surface area was radius r. So that means if the radius changes a little bit, then how much change in the surface area? Okay? The geometric meaning of this is the rate of change in the area with respect to r. Right? Yeah, this is approximated by the surface area changing, right? Now, according to the above formula, it's simple. This is just equal to 4 pi 2r, right? That's the derivative of a with respect to r. So that is going to be 8 pi r. 8 pi r. What does that mean? So that means the rate of change still depends on the rate of change in the surface area with respect to radius still depends on the radius. So if the radius is getting large, the rate of change is also getting large. Okay? So that means think about they have two balls. One is larger, the one is smaller. Each ball increased by the radius increased by 1 inch. Okay, radius just increased by 1 inch. But the smaller ball, for the smaller balls, the area increase is smaller, much smaller, right? If the ball is large, okay, if the radius increased by 1 inch, and the change in the area much larger, okay? So if you have a ping pong ball, the radius increased by 1 centimeter. The surface, yes, the surface area changes. You can see that, but only tiny bit because it's just ping pong ball, right? But if the Earth, you can do the calculation. If the radius increased by 1 inch, 1 centimeter, I'm pretty sure the area increased. The increased area should be much larger than football field. Okay, so that's just because it's 8 pi r. It depends on radius r. Right? Now let me understand the surface area. Okay, look at the sphere, right? So this is the radius. So this part, the cross section, the area is going to be just pi r squared. But there's a sphere, the upper hemisphere, right? So if you divide the sphere into 4 equal parts, like a watermelon cut into 4 pieces, equal. And what you see that because the surface area is 4 pi r squared. So that means each piece, the surface area, is going to be just equal to the area of the disk in the cross section. Yeah, you can do the estimate. It's not exactly the same, right? So that means the surface area, a quarter of the surface area is equal to the area of the cross-section part through the center. Okay, so this is the area, and then that area is also pi r squared. So you have four pieces. Okay. So this is then look at the volume. Right? The volume, if you know the radius, is going to be what? It's going to be 4 pi r. I think it must be cubed, then divided by 3. It's interesting why divide by 3. Yeah, how did I get it? Right? This is the volume formula. Now, the derivative, it's easy to find out, right? The derivative with respect to derivative of volume with respect to radius is going to be 4 pi r squared. Now I'm surprised. This is nothing but the surface area. So the rate of change in the volume with respect to radius is going to be just at that moment, right? It's just for a surface area. Okay. So that means the increased volume from, so this is the increased volume, right? This thing, it's almost equal to dVdr, right? So when you change the radius a little bit, then the volume, the change in the volume, which is delta V, is about the derivative of this time multiplied by delta R. Okay, so in other words, this is about dVd. Okay, it's about area delta. So larger area gives you more. If the surface area is getting large, then the increased volume is getting large. Okay, I think I can understand that part. Let me draw the picture. Okay, so how can I draw two balls? I can draw like that, right? It looks like two balls. Okay. All right. So this is a delta R. This is R, right? So the surface area is A. So A times delta R is just the product. It looks like this is the increased part of the volume. Okay, close to that. If you are able to open the sphere, make it like a flat, then A times delta I is just the volume of the box, you know, the red, yeah. Okay, the base times the height. Yeah, the surface area times delta gives the volume of that region. You can also solve for express the volume in terms of area, surface area. Let's record that, right? Surface area is 4 pi r squared. The volume is going to be 4 pi over 3 r cubed. So I'm going to solve for r. So A over 4 pi, and that is a square, which is a radius. Then I put it here. What I get is going to be A over 4 pi and 3 over 2. Okay, so you can write down the relationship between volume and volume in S area. Now, sometimes you can also express in this form, 3 over 4 pi V equals A over 4 pi 3 over 2. Then you can square it. Okay, you square it. Okay, so that's the relationship between volume and surface area. Now, if you don't want to keep the constant, this will be cube, right? So that will be 9, 4 pi square, V square, and 1 over 4 pi cube, A cube. So I can multiply both sides. I get V square, right? And then we multiply there. I can put here 36 pi and A cube. It looks much simpler. Okay, that's the simplified identity. Okay, 36, 4 times 6 is 36. 36 pi V square, right? So that's the original relationship. Then you can find out the derivative of V with respect to A, right? You can also find out the derivative of A with respect to V, okay? So find this. How do you do that? You differentiate both sides with respect to A. So you get 72 pi V dVdA, and that's 3A squared. Okay, so now you can you can do this. I think it's going to be 26 pi V and A squared. No, it's 24. So that's the the meaning of a dV of a dA is just the rate of change in the volume with respect to A. Let's take a look at, and this is from mathematics. We can also look at some problems from real life. Okay, so here's it says the rate of change of a common quantity in general it's not constant. Okay, for example, when we study the population of the human being, right? Or the population of bacteria, it's the same idea. Just a bunch of So the population is a function of time t. So this is the rate of change in population. Okay, but this is the meaning of this is the rate of change in population. Population is denoted by p. It's a function of t. It depends on time t. In general, within sufficient resources, I say, okay, and constant environment, no change in environment, then the population is the rate of change of the population is proportional to the population. Okay. If you're talking about any certain type of animals on the earth, maybe the case in over a certain period of time, the case is almost constant. But because Earth has a fixed size, you cannot say that we have sufficient resources, food, for example, for human beings, for example. So the population can grow eventually, according to mathematical model, right? If the health, scientists working very hard to improve it, like in the future, you're not going to die of cancer. Most of our disease can be overcome. Okay, and if you still have same ideas, want to have like 3 or 4 kids in each family, and according to mathematical model, eventually get a disaster. So that's a problem. Okay, you either find the new resources of food. You can eat what? You cannot always eat rice or bread, right? You can eat something else. Then it's probably okay. Otherwise, it's a constant. Find a way to control the population or increase the population. There are some countries' population is going down, like Russia. Okay, there are some countries' population is going too fast, like India or China. Yeah, so that was a problem. Okay, so population is proportional. The rate of change of population is proportional to the size. So the constant k is some number, right? The k could be a function of t. Okay, but over certain periods, it's almost a constant. Then you get the equation. This is called a differential equation. If you heard about, right? So you get the equation, and you're trying to solve this equation. Okay, you're trying to solve this equation. It's not easy to solve this equation. Okay. Yeah, it's not easy to solve this equation. So this is probably the first differential equation against you will meet in calculus course. There's also a course just focused on differential equations. Very complicated equation, like a p square, maybe square of the derivative something. So that is course called 266. Okay. So I'm not going to try to solve this equation for p, but I know this is the rate of change here is proportional to its size. Then p can be uniquely determined. Okay. So now let's look at another problem. This is about the cost function. A company, the cost function in producing X units. Okay, let X the cost, okay, in producing X units. Okay, so X. Now let's understand. Okay, when X changes from it's a cost function. It depends on how many units you're going to produce. Okay, but it's not a linear. Okay, there's a fixed cost. In general, it's a linear function, like a fixed cost plus a constant times X. Okay, why have to have a fixed cost? Suppose you want to start a small business. There's a fixed cost. You have to rent a space or whatever you want to do. No matter whether you're going to make a product or not, there is a cost already there. It's called a fixed cost. Okay, and it's in general, it's not a linear function. Okay, sometimes like a cost like the fixed cost plus AX. That's pretty normal. Yeah, right? The more products you're going to make, the cost increases linearly. Yeah, but it's not always like that. And sometimes you hire 7 workers to do them, and then they work, then finally you have to hire 8 and then 10. Okay, and then they have to work overtime. Then eventually you have to hire more. So it's not like always proportional to X. Yeah, if hire more work does not mean it's always a linear function, because if you ask the worker to work overtime a little bit, you just pay them extra salary. But if you hire another person, you have to, as a boss, you have to calculate all the social, all the benefits included, right? It's not like that's why some companies, like a hospital, they don't want to hire a statistician, full-time statistician, because otherwise they have to cover all the benefits. They just sign to the contract. That's one of the choices. So you heard about, maybe someday you work for some company just on contract. Yeah, you travel from state to another state. See that, right? So because why? Because they don't want to hire people or the fix, pay those retirement, cover health insurance, that kind of things. Yes. Okay, so this is an example. So now we let X, suppose X changes from X to X plus delta X, okay? Then the change in the cost will be, it's called the delta C, which is X plus delta X minus C of X, okay? And of course, we want to know the ratio. So this is a ratio, okay? It's really the average rate of change, okay, of the cost. Okay. The interesting thing is, what is the meaning of the derivative of this? The derivative is going to be the limit, but it's harder to talk about the limit here because X only takes integer values. Okay? But this limit, you can assume that when you say approach zero, really means delta X equals 1. Okay? Almost equal 1, right? This is called the marginal cost. The reason is this is almost equal to, if you take calculus for business, this is one of the topics. Okay. So you let the delta X here, delta X equal 1, because delta X cannot be 0.2 units. You can, But so this is it's called the marginal cost. Okay, that means if you produce one more item, how much? What is the additional cost of to produce one more item? Because you have to decide to, you have to do the calculation in order to profitable, right? Okay, so you do need a mathematics to do some estimate. Without doing calculation, sometimes you get in trouble for the business. Okay, so here's the example of the cost function. This is a typical cost function in dollars, 5x plus 0.01 x squared, and this is the initial cost. Okay, and I think 5x means the cost for producing each unit. But why is there 0.01 x squared there? I think the more units you produce, there will be additional cost there. Okay, maybe for the electronic bills, they will charge you more. It's not a, if you look at the electronic bill, maybe no attention. But someday you will see that, okay, why? Because you over certain kilowatts, that IPL charge you more. It's not like a linear function, okay? Because I don't want to spend, use too much energy. So there is an additional charge to, if you spend $100 less, it's okay. If you spend more than, $100, actually it's the rate they charge you. It's not a constant. Okay, it's the same thing. If you make more money, okay, and the tax rate will be different. Okay, the tax rate is different. Okay. In Canada, even pay more tax than the United States because they have more better social benefits. Okay. I was in Toronto one day on the street in the morning. Why people lined up waiting for something? It's like the cafeteria. They get free food. People just have lunch for free. All you have to do is just show them the kind of coupon. You have to get a certificate from the government first. So you are poor, you are not making lots of money, then you can go down the street, you can get free food provided by the government. Yeah. Let's have more benefits. Okay. All right, so this is a cost, right? Then let's find the derivative. cost function. It's not a linear function, I just said that. Okay, so the marginal cost is 5 plus 0.02x. Okay, this is actually is almost equal to x plus 1 minus c of x. Okay, so if you produce one more item, you probably not only pay $5, additional $5, you also have to pay 0.02 times x. Depends on the volume. Depends on how many items already produced. There will be additional charge. Okay, and that charge depends on the size, the number of the units you produce per day, for example, on that particular day. Yeah. So this is not a linear function, and you use that to do the estimate. Okay. At the production level of 500 items, at the production level, let's look at that. Production level of 500 items, right? C prime 500 equals, it's another small number actually. It's going to be 15. So actually, you have to pay $15 for additional item. And then think about that, right? And should you do that or not? Maybe you don't need, you find out it's not worth it. Okay, then you stop that, yes. Yeah, I remember when I was still, he's a small businessman. He said he has to go back home to work because one of his employees not coming today. Why? Because she cannot work more longer time. Otherwise, she's going to lose the government welfare benefits. You know, that's a problem. If you make more money, a little bit more, then you're going to lose more benefits. So it's not like a linear function. You know, you have to constantly make a judgment. I was, that's weird. Okay. Yeah, you have to always make a decision using simple mathematics. Yeah, the cost to yourself, whether it's worth it. Okay. In Canada, if you only make like $1,000 per month, probably it's better to stay home. Why? Because you get $800 benefit from the government. You don't need to do anything, right? You have to make like $2,000 per month, maybe worth it. You have to go out every day, right? Work. You know? All right. So this is. All right. So let's look at the next problem. This is S is a position function. Okay. T is greater than or equal to 0. Yeah. So the velocity is just a derivative of the position function with respect to t. That is the rate of change in the position. Okay? The velocity is the rate of change in position. So that is going to be 4t cubed minus 12t squared minus 40t plus 20. Yes. So that is the velocity, the rate of change in position at the time t. So the velocity at time t is the rate of change in position function, right? At time t, right? With respect to time t, and then you continue. This is a function of t, right? So the acceleration is the rate of change in the velocity. So that's a 12t squared minus 24t minus 40. Okay, that's called the acceleration. So acceleration is just the rate of change in the volume, in the velocity. Okay, and that is the rate of change in velocity. Okay, Now our question is, at what time does a particle have a velocity of 20 meters per second? We also, and we have a number of questions to ask. Question 1. At what time t the velocity is going to be 20 meters per second? Yeah. So our position function here is in meters, and the time is in seconds. Okay. Let's go back to here. This is in S is in meters. T is in seconds. Okay. So then you can say the velocity, the units will be meters per second. At what time t the velocity is 20? So you have to look at what you got, the velocity function, right? The velocity function is a 4t cubed minus 12t squared minus 40t plus 20, okay? And that is going to be 20. Well, in general, it's impossible to solve the equation. Why? Because it's polynomial degree 3. We do have some kind of formulas, but it's harder to find out, okay? It's in special mathematical manual. But if you say the velocity is 20 meters per second, then this 20 cancels out, you will get a quadratic equation. It's going to be 4t squared minus 12t minus 40 is going to be 0. Okay? And you can take 4 out. T squared minus 3t minus 10t. And you can factor this out. It's minus 5t plus 2 equals 0. So how many solutions you get? Since t is always positive or 0, t equals 5, t equals -2. -2 is not included because we only consider positive t. So at t equals 0 and t equals 5, this particle has velocity of 20 meters per second. Okay? And the second question is, at what time there is no acceleration? The acceleration is 0, equals 0. Okay? Then you go back to look at the acceleration formula. The acceleration here is going to be 12t squared minus 12t minus 40. That's 12t squared minus 24t minus 40. And that should be equal to 0. You divide both sides by 4. That'll be 3t squared minus 6t minus 10 equals 0. Then you have to solve by quadratic formula. Okay, you cannot factor it. So t equals 6 b squared minus 4ac. And after you simplify it, you get 36, 120, so 156 divided by 6. Okay, you may simplify a little bit, but clearly if you choose negative sign, you get a negative number. So the answer t is positive, so it's going to be this number. Okay, this is about well, I don't have a calculator here, so we cannot figure it out, but you can estimate. So this is at this time, the acceleration is 0. You solve for the acceleration. Okay, you solve for the time, So when the acceleration is is 0. Now, the last, okay, let's look at the rate of change. Newton's law of gravitation. If you have two objects in the space, okay, if they have the distance r, this one has a mass m, and that's capital M. Newton find out the force attracts each other. F is m times little m times capital M divided by r squared. I don't know how did he figure out this. First of all, on the Earth, you don't feel anything like that, right? If you stay close to your friends, you don't feel anything. Maybe you stay close to your girlfriend, you feel like something attractive. It's getting closer. But I think this is a independent of the distance between you and your girlfriend. Okay, even you're thousands away, miles away, you still attract each other. Okay. These days, cell phone bring each other so close. Okay. And honestly, even it's too close, sometimes it's harder to build a good relationship. Okay. You were wondering when you were separate from each other, right? Only write letters, regular letters. You find out you're bound to each other because you keep writing slowly. Nowadays, people just pick up a phone, talk to each other. Sometimes it's harder to express your true feeling through the voice. Do you agree? Okay, anyway, so this is a two star. Okay, they attract to each other. Okay, they attract to each other, and by this force, it's a reciprocal. This is divided by r squared. So when r is getting smaller, the force is getting stronger. Okay. Okay. Then we want to see the rate of change in the force with respect to radius. Sometimes the radius change a little bit. We want to see how much force change, right? So the meaning of this df dr, right? And this is the r squared in the denominator. So actually you can write in this. Okay. So when you differentiate, just twice GMM r to the negative 1. Okay. So the change in the force, that the rate of change in the force is not constant. It's really still depends on the distance between two objects. Okay. If the radius is very small, if not radius, if the distance is very small, then the force, okay. Why is this negative? The negative means it is decreased, right? Yeah, how do you understand that? Yes, it's decreased. Well, because look at this graph, right? This is R, this is F, right? The force looks like that. When R getting close to 0, the force is getting larger, okay? And then when R goes to infinity, the force is getting small. Okay, this is a graph, okay, for the picture. So when R changes from R to delta R, okay, it's increased, right? When the distance between them increased, then the force, okay, the rate of change is negative, that means decreased, okay? That's how do you feel? I still don't know why, you see, in physics, you always think, there's a gravity. Okay? The question is, what is cost the gravity? Why there's gravity? We only observe this sort of phenomena. As a science major, right? You want to know why. Why there's a gravity? What caused the gravity? I think nobody knows it these days. Yeah. So something, right? We don't know. You can think about it. This is Newton just observed this phenomenon, and he write down the formula, and then maybe it's hard to even do the experiment, in my opinion. It's a larger scale, very larger scale. He probably do the calculation, just observe the moons rotating on the Earth. Okay, but the still question is, why these two objects will attract each other? This gravity is different from electricity, right? Yeah. So I think this is still an open problem. Nobody knows. Yeah. Okay. So we did this problems. I think that's enough for today's class. And Monday, right? Monday there'll be a quiz. Okay. Make sure you prepare for that. And if you're not doing well on the quizzes, and you should do better next time.